you tell us a little bit more about MiMiC's comparison to other simulators that are out there, and how it's better and how this new release is better?
Sure. First of all, MiMiC is a dynamic simulator, and it's not a process design or steady state modeling package that is used to see if you've got enough trays in your column, if your heat exchangers are sized correctly, or even your control valves are sized correctly. MiMiC is a dynamic process simulator. We first of all start off that the process is designed, and we want to provide a dynamic simulation of that process that not only handles the steady state conditions, but also handles the transitions between the steady states, because that's the key thing. And it's going to be dynamically updating values back to the offline control system. In addition, MiMiC is a dynamic simulator, but it's also designed specifically for operators or control system testing and operator training. So it really is designed to work with an offline control system like Emerson's Delta V Simulate or Schneider's Unity PLC simulator, or Rockwell's SoftLogix product. So it's unique in the industry that it's really focused on that discipline: testing your application software and then operator training. With MiMiC version 3.1, we essentially rebuilt our complete simulation capability we had with our previous versions of MiMiC 2.8. It's what we called the last version of it. And we rebuilt it with the latest in software technology. It's built around .NET, open interfaces, XML data exchanges, SQL Server database for repository for simulation data, handles multiprocessors, so we always say, you can just buy more and more PCs and make your simulation bigger and bigger. It handles dual core, quad core, 8-core type machines. It's very scalable, very flexible, and built very much to be easy to use.
Can you describe some of the new features that it has?
Well, with version 3.1, which is released here again right before Christmas, we've got a brand new enhancement to the Operator Training Manager. The Operator Training Manager allows you to build structured operator training scenarios, so that once your dynamic model is in place, now you can have a structured operator training session that is repeatable and also is measurable. In the Operator Training Manager, you can define scenarios that have malfunctions, and setting these up is very simple and easy. And each malfunction can be impacted into the models. It can impact the models, or it can impact the offline control system. So the Operator Training Manager sits over both of them. It also has scoring conditions for each malfunction. So you can set the expected results you want the operator to take the process to, or how he wants to respond to it. And you can give it a weighting, and it will automatically generate a score. So you get a quantitative result for the operator training session as well. And then we save a operator training session report in HTML, rich text format, or PDF. So you have an ongoing permanent copy of how that works. With version 3.1, we enhance it quite a bit. We also have a new enhancement to our graphical process flow diagram product called Component Studio, where you can do all the controls of your operator training sessions in there. Have a really easy to use, very quick to set up instructor station.
What can you tell us about what's behind the technology that you're providing, and how are you able to achieve this? Is it just all in programming? Is it?
Yeah, just lines and lines of code. Yeah, but it's we use. I can tell you exactly. We use the latest in software technology, the best, what we think are the best practice software development for real-time systems. We run on Microsoft products because everybody else there does too. And we've released on XP, Server 2003. We're probably going to be released on Vista as soon as people start using it in industry. And we implemented our product completely in C++ programming libraries, Microsoft Foundation class and .NET libraries. because of that, we don't rely upon Visual Basic and other things, because C gives us the ability to really control the machine, to control the processes. It's really the best approach for doing really good software development. Our simulation product is built around a simulation engine that's real time. It's a proprietary development that we developed and designed. It feeds data, it stores data and feeds data to a SQL Server Express database, again another Microsoft product, and then it works with a simulated I/O function called a simulated I/O bridge that services and provides data to the outside control system. Operator Training Manager, other functionality are just add-ons to that whole product. So it's a very simple architecture, but very efficient, and can be scaled from small simulations of 1,000 I/O or less up to 30,000 I/O.
Okay, going back to what we were talking about before, could you give us an example of a scenario a training scenario that you might walk through?
Sure. So you've got a dynamic model put together for, say, a distillation column, and you want to then add what happens if your recycle stream pump around all of a sudden fails. And how does the operator respond to that? Take the column to a safe state, essentially shut things down. So that may be a very simple scenario. You fail that motor. And in MiMiC, it's real simple. You just say, you go to the dialog box, and when you build a malfunction, you say, you select fail as one of the actions, and you pick the tag name of the motor. You're done. And then what do you want it to do? You want him to take the mode of the control of the flow loop for the feed to manual. You want to then take the applied valve position to a certain point. Maybe you cut down your heat exchanger duty so you don't overboil the column. You go through whatever you need to do there and you build those as scoring conditions, and it automatically then calculates how he does.
So he or she is able to achieve a right or wrong answer, essentially.
Right. Or shades in between, right? You decide what is an acceptable score, what is a failing score. What's the best approach overall. But the operator sits there on the control system MMI, and at the same time is working with the same operator graphics, the alarms, everything that he would in the real operating plant. We want the operator training experience to be so realistic that he has sweat on his brow when he's done, when he's trying to bring the column back under control, just like he would in the real plant.